We do not know how big the universe is. All we know is the size of the part we can see. In 2017, China launched its first X-ray astronomical satellite, the Hard X-ray Modulation Telescope, or Insight-HXMT, into orbit. The Insight-HXMT satellite contains 3 collimated telescopes: the High-Energy X-ray Telescope, the Medium-Energy X-ray Telescope, and the Low-Energy X-ray Telescope. These allow researchers to study the galaxy's neutron star and black hole X-ray binaries. Unfortunately, the performance of telescopes may gradually degrade due to several factors such as detector radiation damage. Furthermore, the high-energy charged particles can activate specific elements in the detector, resulting in an increase in the telescope's background level. To meet the accuracy requirement of scientific data analysis, the background of the telescope must be accurately modeled, and the energy response matrix must also be accurately calibrated. While the Insight-HXMT mission explores the universe, it has been helping scientists to understand the evolution of detector performance over the past 5 years. Today there are 5 leading publications on this evolution by the researchers of the Institute of High Energy Physics, Chinese Academy of Sciences. During the 5-year study on high-energy X-ray telescope, XF Li et al. Assessed the gain in the energy resolution of the sodium iodide and cesium iodide detectors, the performance of the pulse shape discriminator and the system dead time. The results showed that the overall performance of sodium iodide remained consistent, but the gain of cesium iodide rose continuously. Yet Tan et al. Research on medium-energy X-ray telescope describes the monitoring of the silicon pin detectors utilizing onboard radioactive sources and observations of the Crab Nebula. The findings disclosed that 742 square centimeters of usually functional silicon pin detector pixels remained after 5 years of operation compared to the initial 952 square centimeters. However, the telescope's gain rose gradually by 1.43%. Meanwhile, XB Li et al. Described the evolution of the low-energy X-ray telescope's performance using the Casa supernova remnant, the blank sky, and the Crab Nebula measurements. Compared to high-energy X-ray telescope and medium-energy X-ray telescope, the changes in the performance of the low-energy X-ray telescope were notably more significant. Its energy resolution at 6.4 keV deteriorated by 100 electron volts, and the energy gain at 6.4 keV also decreased by 4% over the 5-year mission period. The systematic errors in the spectral fitting are lower than 1.5% in 1 to 10 keV after continuous calibration. The paper 5-year in-orbit background of Insight-HXMT by J.Y. Liao et al. Describes the 5-year in-orbit background evolution of Insight-HXMT since its launch, as well as the validation of the background model. The major observational characteristics of the Insight-HXMT in-orbit background for each year, including the light curves, spectra, geographical distributions, and long-term evolutions, are consistent with the predictions based on satellite design and space environment. The systematic error analysis of the background estimation for each year indicates that the background model remains valid for the latest observations of Insight-HXMT. The Insight-HXMT satellite has made several observations of the Crab pulsar for in-orbit calibration. In the 5th paper, H.S. Zhao et al. Studied the long-term evolution of the X-ray flux of the Crab pulsar with observational data. They concluded that the X-ray luminosity of the Crab pulsar closely correlates with its spin-down power. Yet they need more work to understand the emission mechanism. The Insight-HXMT mission provides a better understanding of the performance of X-ray instruments in space, which can inform the development of new space technologies and promote innovation in astronomy and astrophysics. As we continue to explore the universe, the knowledge gained from missions like Insight-HXMT will undoubtedly play a significant role in helping us unlock the mysteries of the cosmos.